Okay, well, welcome back after lunchtime, everyone. My name is Jamie Gillespie. I work with Adley at APNIC as one of the security specialists. I'll be chairing the afternoon sessions today. We do have microphones that will be up at the front if anybody wants to come up and ask questions through the presentations. For this next session, we have two presentations, go for approximately 45 minutes each. First presentation that we have is from Suman from Amber IT Limited and Alan from Pipeline Security on DNS firewall security. So if I could invite you guys up to the front. And I think we're back to recording and streaming of this presentation. So assuming everything's okay for pictures for this session for you guys? Yep. So yeah, so we're back to normal presentation mode of pictures and public information. Both mics are working, so Walker.
Sure. You wanna go first? Yeah. Can I start? Come here, start. Start. I mean? Okay.
And clicker if you need it to advance.
Hello, everybody. Hopefully you're not too tired from the big lunch that you've just had and we don't put you to sleep. My name is Alan Watanabe. I'm with Pipeline Security. We're here to talk about a use case or a test case that we had with Suman and Amber IT. I'm originally from California. I currently live and work in Tokyo, Japan. And we're focused on security, and we'll try to share some of the details that we went through in our test.
Okay. Hi, this is Shuman. I'm from Ambarte is my company. I'm from Bangladesh. Ambarte is one of the major ISP in Bangladesh. And this DNS firewall we have implemented last year, and we show its outcome. But this time, how we will meet with Alan from these two regions. So we met with Alan and we improvise it, and now we want to show a better use case and with the how we can use it as an anomaly detection. So hopefully, so I asked to Alan to tell in details how we meet and how we start to work together.
Yeah, so actually this is my first attendance to this event. And I knew of APNIC, but I didn't know about the conferences. And about 6 months ago, I was looking and researching around DNS security, and I just happened to find Suman's presentation on Linkshare or ShareLink. And he was talking about DNS security. And so he had kindly shared some of his details. I pinged him on LinkedIn. And I said, hey, why don't we try to do some testing with some of the data that we provide and see what kind of results we get. And fast forward to here, we have some good results to share and ready to start the presentation.
Yeah. So as an internet service provider, we are thinking to provide a safety wall for all our customers. So at opening ceremony, Gaurav was talking about make internet better for everyone. So we are thinking the same thing, like to make the internet safer, that will be imposed to everyone of our customer. If we do anything like if we build a firewall, or whatever it is, container firewall, or if we implement some ACL, that if we implement ACL, that is not that much perfect. And if I implement ACL that much, so it will increase the router processing and the quality of internet will decrease. So we are thinking what we can do for our customers so that they can come to our safety net, and we can better visualize our network. Is there any anomalies? If there is any host who is infected or trying to connect to any botnet or trying to connect or any malicious site trying to go to any coin blocker or crypto miner sites. So it's also was needed for us for better visibility of our network. So for all, and one thing we try to keeping in our mind, if we implement a solution and if we need to change anything in our customer's end on any CP device, that will incur more cost and more involvement for to implementation, and it will slow down our intention that we want to gain from this implementation. So we are thinking to do trying to do something from the DNS server. So as DNS is the core infrastructure in internet. So so every whatever you go, wherever you want to go, core infrastructure of internet, you have to use. First thing is an IP. You need to rely on BGP, and second thing is DNS. So if we want to do anything, if we can do anything on DNS, that can be better, if that can be effective, and that can be imposed to everyone who is using our internet. Oh, really? So how domain name is involved in the in most of the incident. If we go to Cisco annual cybersecurity report, it shows 91% of malware uses domain names. That means if we can restrict those domain names, we can gain this 91% of malware to connect from our customers. And then we try to start more with a DNS response policy zone. With DNS response policy zone, we can impose our own data from the DNS recursive query. So for every recursive query, through the DNS response policy zone, we can impose the data that we can want to redirect to the users. That means we can redirect our customer in a walled garden for those requests that will be go to malware destination or botnet destination like that. So DNS firewall is a tool that was from DNS response policy zone, and that was invented by Paul Vixie, and it has a draft IETF RFC, and that is Paul Vixie. What he said, DNS firewall gives you the most bang for your buck. So that was actually we are looking for. So hopefully that is our solution. So if I go quick, this is the DNS infrastructure. So if we want to resolve any domain, we have to go to the recursive process, as we know all. And through the recursive process, we go to root server, then to TLD servers, and then to the DNS servers, we can get the IPs. And in DNS servers, there is one master and there is a slave servers. So slave server copies the data from master servers. And what we do in response policy zone, We take this data feed, master data feed from a security company, where we can get the domain names or IPs, who is infected, who is botnet, who is the crypto miner websites, who is the malicious website. So we can create a local database here, and if any customer, if any user want to go to the malicious destination, we redirect it with another response. So, I can go quick. So how is DNS response policy zone is different from any other blocking list? If I want to use any blocking list from my own PC or system, that need to be synchronized every time for any service with this RBL. But for this case, our DNS RPG, it only update its recursive server, and we don't need to do anything in the endpoint. So in a session from Sohako from JPCert, Adli had a question, can we do anything from endpoint to anything like anti-malware? So that is really, that can be a solution, but what we try to do, we want to put this safety net to all, so that it can be, we can create a tools for anti-malware, but I can guarantee everyone will install that, or everyone will be used that. But everyone need to use the recursive DNS server to go to internet. So if we can filter from here, then that will be effective, and that will be usable to everyone. So I asked Alain to continue from here.
Thanks, Aman. So I think some of this stuff many of you guys and ladies are quite aware of, but we wanted to go over some of the basics. And basically, with the DNS RPZ solution, there's a number of data that you can feed into your DNS. And the reason why we thought DNS is a critical piece of software and hardware, I mean, obviously it resolves the domain names, but I mean, everything that is connected to your infrastructure and the internet basically goes through this. And if you actually analyze the logs, you can actually pick up a lot of things that you normally would not. And there's a lot of security companies that are pushing what's called like a SIEM or a CM and doing log analysis and correlation, where in fact you have a DNS server that is actually already kind of doing this. And obviously this isn't going to pick up everything, but I mean, we think 80 to 90% of badness and stuff that's out there you can kind of filter out and look at. And so the DNS server is there in your environment. You feed it what's called an RPZ feed. There's a number of different options in feeds. Primarily, we recommend malware and of course, CNC hosts, just because of the general badness. But aside of that, you can also put OPSEC feeds, your own custom feeds, and to improve the security profile for your network. And basically, in some of these attacks, and attack surfaces. Some of the things that I've been hearing throughout this conference is, many people are concerned about this automation, botnet activity, malware, and people are trying to figure out problems that are very complex. And if you look at some of the things that criminals are making out on the internet and that are just generally available to the public, it gets quite scary. Some of the stuff that is out there now, for example, and most of you probably are quite aware of, is like the Mirai IoT bot. There's the Avalanche, Black Hole, and Zeus, and there's many more that are coming out. I think late last year there was something called Black Grid or something that is a botnet that is targeting critical infrastructure, nuclear power. And so there's a lot of things that are getting even more scarier as we get more into IoT and IPv6. So some of the things that are malicious, obviously, because it's handling DNS, we see a number of malware and ransomware trying to redirect or spoof DNS. And so one of the things that can occur is you can get infected by these automated attacks, in which infects a node, and it's trying to say, update its virus software, or even a patch management server, and it's getting bogus, replies or responses, and it's not able to fix these CVEs or these critical patches that need to apply. And basically, this goes to everything. I mean, security updates. We're seeing things that are obviously attacking banks and financial systems. Crypto is very prevalent in the space. And then you have sites that are legitimate and then just abused. So sadly, our website was 2 weeks ago attacked, and we got infected by a crypto miner. And the scanners that we had didn't pick it up. And so one of our guys, tech guys, said, hey, there's something weird about this redirect from HTTPS. And sure enough, in the header, there's a small script that is redirecting traffic, taking users to a malicious payload. And then so with automation, and I'm sure many of you have networks that you're monitoring, and you see a lot of automated scans. I mean, basically, there's a lot of automation out there trying to find things that are vulnerable. And, we call him the bot herder, and he's over there on the left. Basically, he's trying to get login information, passwords, anything to get access into your system. When we do red teaming or pen testing, the first thing that you kind of want to do is scan the perimeter. And the easiest way to get in is obviously email. So you send an email full of payload, and it starts to infect and goes infecting the infrastructure internally. What happens from there is those nodes need to communicate to the botnet and to be basically given instructions on what to do. And so now, once this happens, it's infecting things inside your infrastructure, talking to the botnet, and pretty much in most cases, it's talking to DNS. So if you're looking at DNS, looking for botnet activity, I mean, the DNS is a goldmine for information. And so I found this sample online. Basically, these are some domains that you can see. And so can you guys tell me, or ladies, tell me which one is real and which one isn't? And it's a trick question. So basically, these are all bad. I mean, even from a human eye, it's very hard to tell which one is good and bad. We're getting into domain names with multi-code, Cyrillic, alphabets. In this sample, many people will say this is the real one, but in fact it's not. If you look at the A, it's different from everything else. But from the human eye, it looks legit, and so people will click on it. And so the criminals obviously are very smart, and they're getting into things that are easy for us to get into and really step in the doo-doo. And so I was very happy to see Shoko-san was talking about a very big use case. And so this is the way the RPZ mechanism is used and how we can actually block some of that traffic. But let me take you into a use case. And so I think Shoko-san from the JP CERT had also talked about this. And we were also very curious and looking at this as well, because we're seeing a lot of spoofed domains going out onto the wire, and they're using some of these tactics where they're essentially recreating all of these websites that look super legit. I mean, if you were a user, you would probably not be able to tell. And the domains, to be honest, look pretty real. And some of these, of course, look kind of awkward if you're not, or if you're part of the company, you can kind of point it out. But if you're a user, it's really hard to tell if it's real or not. And the workflows that they think about are very natural. And I mean, if I was a Sagawa employee, I could easily be hooked on this kind of scam, where I'm going to a legit-looking website, automatically getting pushed to download an APK which says, hey, you need this to accept your package or respond, and then they get infected. So it's actually a very complex ecosystem that people are up against, and these attacks are getting better and better. And so with some of the possible use cases, again, because DNS has a lot of data, you can actually just do correlation there. It's very low cost. If you already have a DNS or you're managing and you're looking at logs, I mean, you can basically go to OSINT websites, grab a few pieces of log data, and do some correlation there just to see what kind of traffic you're getting into. And I think Suman will have some good samples later, but basically these are some of the things we can do. And I mean, of course, you can detect, you can stop, but I think a number of people forget is, I mean, you can protect IoT devices that don't have security measures. If they're burned in root passwords, it's very hard to protect. And so with DNS RPZ, you can actually stop some of that, or at least monitor. And then you can also track what's on your own networks to help sanitize.
So we actually will show a use case. So we have used a recursive DNS server. We have tested with both bind and with Power DNS recursor. So every operator has obviously had DNS server, DNS recursive server. So if you just implement this RPG with a response policy, so you need to rebuild the bind if it is really old. Otherwise, it is this feature is already built in. So it is very easy to implement. It's not less than a task for 60 minutes. So if we use open source, we can use bind or Power DNS recursor. If it has also DNS RPG also implemented in some commercial products too. So what actually we are doing with RPG, if we want to, if any user want to go to a host like host.filter.com, so if we use this rule like cname, and if we put a dot, the DNS server will respond with a non-existence of domain. In DNS header, it will like that NX domain. So if any user, like if host.filter.com if it's a malicious domain, and if user want to go there, then it will be filtered. And how actually DNS response policy zone works. So it has some trigger and some policy triggers, and some 5 policy triggers it has, and 8 policy actions. So we are actually imposing intelligence in the name server. So it works on some triggers, and it imposes on that triggers, it imposes the action. So what are the triggers? Triggers is QNAME is the most widely used because when we actually do a query to the recursive name server, it goes with the QNAME. And RPG IP is the, if we, it actually important when we want to whitelist any IP, like maybe this RPG IP in my threat intel database, but hopefully it is required by some users. So we can whitelist this IP from our policy zone. And same for RPG NSD name. So if any name server is in blocking list in the RPG database, in the threat intel database, we can trigger this query with this RPG NS domain name. It can be also possible with name server IP, and even it can happen. We want to exclude any user IP from this policy, or we want to impose a special policy for one user. So we use that trigger, RPZ client IP, for this case. And this is actually the actions of what we will do if it match with the trigger. So given is the default, so it will be its action will be as given in the threat intel database and RPG database. And others, I don't want to go in detail, but I want to just two or three. NX domain is most imposed. So if any user want to go to a command and control destination, we will reply with NX domain so that user won't get the IP of that destination. And pass-through is if we want to use this response policy zone only for logging mode, like we want a visibility for our network, which IP is going to those bad destinations, but we don't want to impose a blocking. So in that case, we use pass-through. In that case, traffic will be passed, but we will get a log for that, which IP is going to that destination. So it is a bit safe for as a provider, because if we go for blocking, sometime it can happen. Some user may complain, I can go to that destination. So we actually used pass-through for the beginning of implementation. So we have checked how it is working, and we have checked the log for about 2 weeks, how the users going to those destinations, and we checked it if there is any major issues, and we have started to use the NX domain policy gradually. So most important thing is logging. So visibility is most important. Other than filter, we have to that have to be visible that a threat in my network. So we use the bind logging tools for that. So bind already has that category to log RPG. So we use the RPG category RPG for logging the RPG log. So that is actually our experience of before implementation. Before blocking anything, we will actually keep it in logging mode. So we will see the effectiveness of it, and we won't block anything, so that if anything false positive happen here, so that we can understand here from here. And one important thing is some internet users use the OpenDNS or like Google DNS. In our country, 8.8.8.8 is very popular. So to implement this, users DNS recursive query has to come to my response policy enabled DNS servers. So if user go to the any name server other than this, it will not be imposed to him. So in that case, we have redirected all the DNS query to our name servers. So we actually implemented this service to the retail users. So we have redirected all the requests. That is also a bit easy because we are using another DNS server before. So when we have, because our DNS server was really old, so we have used another, configured another DNS server. So if we change if we change the DNS server IP to every users, it was really impossible, and it was a task for a few days. So we tried to avoid that, and so we redirected all the traffic to this DNS server. And that is also important, that we are also wanted to provide a safety net to our users. So if we can redirect their request to the same servers, that will be imposed in the same way. So one important thing is RPG feed. That how I actually meet with Alan and Pipeline. I have network and I have the DNS servers, but I have no threat intel data. So in that case, there are some vendors who have the threat intel data, and anyone can use their data for some period without any cost for the POC or like that. And I want to show how actually it is easy to implement. So I have implemented in our ISP, and at first I have already mentioned that, and we have our DNS server is 9.11.3, and okay. So I actually want to show, it is very simple. So I won't go to more details on the installation part, but I just want to say it is very simple to implement. So it will not take more than 60 minutes to implement. And for our case, we have implemented with a Ubuntu server, and not in a cloud cloud server that is on LXD, Linux LXD. So we haven't even used a new hardware for that. We have used the existing hardware. And that is actually the response policy zones we used for this service. Bind currently support up to 32 response policy zone. So we can't use more than 32. So first one is RPG local. So that is our own database. That means if we want to impose anything other this threat intel database, we will put the entry in the RPG local. Because if if I get any false positive, so we will whitelist that false positive in the RPG local. That is actually how we will collect data from the vendor. So we just mentioned the zone name that I have shown before, and this is the same as the secondary name server, and this is the master name servers. That is actually threat intel DB providers name servers. So we will just building the database in our local, so that it can be happen without any time lag. And yes, it's really very easy to take log and to implement it. So so what I can get from the log. So if any user want to go to a RPG log, it will not log all the DNS query log. So we are not taking log of the users all the queries. Like if I want to go to Google or Facebook or any legitimate sites, we are not taking that log. RPG taking only those logs whose destinations are in the database. So in this way, we are its resource utilization is also can utilize less resource because it's not taking all the DNS query log. And what I can get from the log, this is the user's IP, and this is his destination. So now and this is the what type of destination it is. If it is matched with a zone like malware, so we know this IP going to this destination, which is a malware destination. So this is this is true for the all destinations. If any IP try to go to any destination, if it is in that response policy zone, we can get it from the log file. And that is actually the whitelisting that is important from the operator perspective. Sometimes we can get some query from the users. They can go, suppose some users may need to go to crypto miner sites. He may be a gamer or like that. So we need to whitelist those services, because we can't tell our customer, you can go to that site, so we can prohibit him anyway if he asks us, because he is paying for us. And one important thing is visibility. So till now, we have restricted the traffic that is to the botnet and malware. So then we have used ELK to process the log. And from log, we are transporting the log with the bits to our ELK stack. And we are getting log in the now in transporting the log in the ELK stack. This is the same log that we have shown in the bind log. And this is actually the day one result. On day one, we got 1.3 million queries to RPG zones. So that's huge actually. And top 5 result was crypto miner websites, malware websites, and there was some IP, and there was some, this was the IPs who are going to those destinations. And these are the hosts, actually the malware and malicious hosts. So this is the top categories. This is actually the last 24 hours, from last 24 hours data, like JRD, bad name servers, and botnet, bad reputed, phishing domains are in the top list. And so this is the top, and can you see the count? It's huge, and it's only from 24 hours. And sampling rate is not that much, maybe 10,000 clients IP is coming to these servers, and the numbers are really high. So that is actually we wanted to see how many users actually going to those destinations to a better visibility of our network. So that is actually the top host that is the destination from our users. So first one is the JRD, 0-day domain. So this domain actually registered on 25th, but see the count by only 24 hours. So definitely this is not a legitimate one. And yes, ComSurfer is also in this. I have just tried to go a bit deep in that. What is the ComSurfer? When I matched the who is ComSurfer DNS, I went to the ComSurfer DNS. I got, there are thousands of domains like this that domain is hosting. That means hackers actually go in united way. They remain together. So I got that the same DNS servers actually using for, there are many thousands domain in that DNS server. So the same DNS server using for the many incidents. So that is actually, I show you there is a zone of bad name servers. So if we can filter the bad name servers, we can actually filter many thousand bad guys. So this is the count for our IPs. Okay, so I actually tried to go a bit deep of some incident. Like I show you, there was a crypto miner destination was Pabian.com, and I saw that incident actually was from 2008. And Kaspersky got that on 2008. And 2012, Microsoft files a lawsuit against this crypto miner site. But still, it's persists in the network. That means bad things really can die in a short time. That means it can persist even for many years. Pabian.com is actually a bad fabricated computer, and we are actually getting this request from one of our customer, from the home-based customer, and his millions of requests coming to this destination. So we contacted with the customer. So he actually not doing anything. So, but it is happening from his system. So that is actually the reality. Bad things can go within short time. So I have given some details on that. It is actually in some Pabian.com is some malicious activity. So this is actually our dashboard to better visibility for any type of host like malware. So who is actually the malware IP? What is the malware destination? When it happened? How many counts are there? And this is our dashboard to monitor the incidents, and that is actually a really, yes, the huge counts are there. So we used all the open source tools. There is nothing commercial. So except the data, we have used also in for POC. So, and other than this, we have used all the commercial tools. Hopefully, that will be effective for you if you want to implement. Thank you. Any question?
Is there any questions at this time? Any questions? Got 1 or 2 minutes if we need it. Actually, I had one quick question. You were talking at one stage about the blocking access to other DNS servers, which is pretty straightforward. The other one you were saying was redirecting people. Was it simply just chaining your existing DNS server off to your new ones, or were you doing fancy redirection for the DNS requests?
No, yes. We actually use the threat intel database. So for redirection, we are depending on threat intel database. What if
redirecting from your old DNS servers traffic to point to the new DNS server?
No. We have redirected from the router. So with the router policy, we have redirected all the DNS traffic to the new DNS server. It is actually POC. So when we haven't used that for long because some clients may have their own DNS servers or not that. So that is actually, we did that to impose that to the whole bunch of customer. Otherwise, someone may use another DNS server. These security safety net will be imposed on him. So that was actually the intention.
Excellent. Well, if everyone could join me in thanking Suman and Alan again. Thank you very much. Now we have a presentation from Philip, how do you pronounce your last name? Paps, okay. Philip Paps from FreeBSD Foundation, looking at improving FreeBSD security advisory process. So I'll hand it over to Philip. Thank you. Did you want to walk or?
I don't know. I'll try not to make everyone dizzy by pacing back and forth for several miles. Thank you for the introduction. My name is Philip Paps. I'm from the FreeBSD Foundation. I'm also a FreeBSD developer. I'm no longer actually a part of the security team. I won't say that removing myself from the FreeBSD security team has improved the security advisory process, but I'm no longer a member of the security team. This presentation is actually stolen from our security officer, Gordon. And I've never presented this, so I might go through this a little bit faster or a little bit slower. We'll see how it goes. Feel free to ask any questions you like. Let's see if I can break this thing. So for those who don't know, I'll start with a brief introduction of what FreeBSD is and begin with a little bit of terminology, because the word FreeBSD actually means three different things. Primarily, FreeBSD is an open source Unix-like operating system that's descended from the patch sets to the original Unix kernel, which was, well, the patches were made by the University of Berkeley since the early 70s. So BSD's been going back for a very long time. Our commit history in the FreeBSD repository actually goes back to 1993, but someone's gone and reconstructed the history going back further in time, all the way back to the 1970s. It's actually really nice to see if you go through a file like shutdown.c. It was born in 1972, and then since then it's kept changing. The FreeBSD project then is an active open source community, a community of people who share a vision of developing an open source operating system. And the FreeBSD project got its name in April or June, I think, 1993. So are there any people in this room who were born after 1993? Probably. So the FreeBSD project is a community, and the FreeBSD project develops the FreeBSD operating system. And in addition to developing the operating system, the project also manages the infrastructure to support the open source operating system. So we run our own Subversion repository, we run our own bug tracker, we run our own mailing lists, lots and lots of mailing lists. We don't, we don't live on GitHub like like most newer open source projects. We don't live on GitHub. We have a history that goes back well beyond before the times when GitHub was even a thing. So we're a very active community. And finally, the FreeBSD Foundation, also called FreeBSD, is a non-profit that was started in 2001 to try to provide some legal personality to this loose band of hackers who develop the operating system. So the FreeBSD Foundation is it's a charity. We take people's money. If you've got too much money and need somewhere to put it, the FreeBSD Foundation is happy to relieve you of this burden. And among other things, the FreeBSD Foundation pays for my travel to this sort of events. But more importantly than sending me to events, the FreeBSD Foundation pays for the infrastructure on which the project runs. So we own the servers which run our revision control systems, our bug tracker, and all that sort of stuff. And more recently, we've also started paying to support our security efforts. Who uses FreeBSD? Well, everyone in this room uses FreeBSD. It's almost impossible to use a computer without using some kind of FreeBSD technology. You might not use the FreeBSD operating system directly, but you're certainly using some derivative software. So large consumers of FreeBSD are companies like NetApp, who have taken FreeBSD apart and made it into their own operating system. Apple has done something similar. They've taken large chunks of FreeBSD, in particular the network stack and some of the POSIX stuff, and stuffed it into their operating system, which is known as macOS and iOS, and it runs on your iPhone. You know, that's not to say that FreeBSD runs on your iPhone, but a lot of technology comes out of FreeBSD and ends up in your iPhone. WhatsApp and Netflix are more traditional consumers of FreeBSD. They use our operating system to enable their technology. So if you use WhatsApp, their servers run on FreeBSD. If you use Netflix, last statistic I heard, they're pushing 15% of the traffic on the internet through a CDN that's running on FreeBSD. So all of these companies use FreeBSD in one way or another. So all of these companies are affected by our security bugs. I'm not sure how that makes me feel. Responsible is not the word I would use. Culpable, maybe. But why do these companies use FreeBSD? Where do we excel? Well, we are a very friendly and professional community, he says humbly. We have many very active contributors and committers who've been working on this operating system for a very long time. If you look at the FreeBSD community, we're slightly older on average than many other open source communities. Many of our developers have been working on FreeBSD continuously for 10 and even 20 years or more. We've got FreeBSD developers who've been working on BSD in one way or another ever since the 70s. So our community is a very stable group of people to work with. We don't really have a large turnover, which makes us appealing to companies who want to support products for a very long time. We also like to teach and mentor people. So when we invite someone into our community, we run them through a process of mentoring where we basically put them in a tumble dryer and surrounded by all of our processes, and we brainwash them until they really believe the way we do and they follow our processes. FreeBSD also has a lot of documentation, and we install this documentation together with the operating system, so you can go and live in a cave with FreeBSD and be productive without access to, say, Google or Stack Exchange. And finally, our license is a friendly, business-friendly 2-clause BSD license. We don't try to control what you do with your code. You just take our software and you integrate it. And this is also interesting from a security perspective. When you look at GPL licensed software, you need to tell other people that you are using the GPL because you need to release your changes with it. With BSD licensed software, this is not the case. You take our software and you integrate it, and then you put it somewhere in production, or you put it in a device. Our software is still in there. We have no idea that you are running our software. If Apple had not told us that, hi guys, we're putting BSD in macOS, we would not know about it. If Juniper did not tell us that Junos is essentially a fork of FreeBSD, we wouldn't know about it. So when there are security vulnerabilities in FreeBSD, we don't necessarily know who all our consumers are. We have no idea. We have no way of knowing. Our license says that, hi, here is some software. Feel free to use it in any way you like. And if it breaks, you get to keep all the pieces. nowhere in our license does it say, please tell us you are using FreeBSD so that when we've broken something, we can tell you so that you can pick up our fixes. So we find that FreeBSD in the wild there's going to be a widespread of old versions of FreeBSD that just never get updated because we don't know about them. We can't tell the people who are running them that they're running old software, and they're under no obligation to tell us that they're running this. So where does FreeBSD historically not excel? Well, we don't have a great track record of timely handling of security vulnerabilities. So we have gotten better. That's part of what this presentation is about. But because we are a very large and diverse code base. So the FreeBSD project isn't just a kernel like Linux. We're not just an application like Mozilla, or we're not just we're not a networking application. We're not a mail client or a mail server. We're a complete operating system. We distribute a huge number of things, and our community is comparatively small. We have maybe a couple of hundreds developers working on the operating system with vastly different experiences and interests. So on the one hand, we've got the kernel, and okay, we say the kernel, great, you've got a kernel, wonderful, but the kernel is a massive piece of software which contains, among other things, a network stack, a storage stack, a huge number of device drivers, and a virtual memory subsystem. People who work on networking and write secure code in the network stack to make sure that packets get from point A to point B without being lost, mangled, or corrupted, have no interests or experience with storage. So if there's a bug in the storage stack, network stack developers won't be able to fix those. Well, they might be able to fix them, but they have no interest in diving into the storage stack. Likewise, people who work on device drivers might not know how network stacks work. So I mostly work on device drivers and network stacks. I have no idea how storage works. I know that people who work on storage, tend to be very careful people because in the network stack, error handling is easy, right? You drop the packets. In the storage stack, people get very upset if you kernel their file system. So I have no pressing desire to go and work on storage. If there are bugs in the storage stack, sorry, someone else will have to do them. And that's just a kernel. We also have userland. We have lots of libraries and lots of applications we distribute together to run on top of our kernel. If there's a bug in some library, then a kernel developer is not going to be terribly interested in fixing it, or might not know how to fix this bug. And that's our stuff, the left side of the screen. This is software we've developed and which we maintain ourselves. On the right side of the screen, then, we've got third-party components because we write an operating system. We are not going to reinvent all the wheels. I think we've invented a large enough number of wheels to be getting on with. But we pull in a lot of third-party components. Among other things, we pull in OpenSSL, we pull in OpenSSH. We still have SendMail because we don't think you can be a Unix-like operating system without including SendMail or some means of sending email. We've kicked out Bind. We did that during EuroBSDCon about 5 years ago. We were sick of Bind. We're not distributing Bind anymore. We're done with that. Historically, about 80% of our security advisories were Bind version updates because Bind was broken. So we've replaced Bind with Unbound, which has a much better security track record. And we still distribute NTPD as well. So all of these third-party components, which we distribute together with FreeBSD, can also spring leaks. And when you use FreeBSD as your operating system, you expect to get a security advisory to tell you that, hey, you are running FreeBSD version 9 point whatever, or FreeBSD version 11 point something else, which comes with NTPD version x.broken. We have pulled in version x. Not quite so broken. Please update your FreeBSD to this version. So the FreeBSD security team needs to track these third-party components as well and update them. And again, there's a matter of manpower. A kernel developer who's working on the storage stack is not going to be terribly keen on tracking NTPD, updating it, and then writing a security advisory about it. And then finally, FreeBSD comes with a ports framework which allows you to install third-party packages such as web browsers, file managers, desktop environments, all that sort of thing, which people actually want to do with their computers. Because an operating system, people don't want to use an operating system, right? An operating system is boring. People want to do things with their computers. So we give them a collection of about 35,000 binary packages, which we follow the upstream release processes, and we keep these packages updated. But when something like Mozilla springs a security leak, the version of Mozilla which we distribute should also be updated in our source tree, so that our users who are running Mozilla on FreeBSD get the latest version. Likewise, Apache, Nginx, any old thing that can break, we need to keep updated. So, vulnerability response, what do we do in case of a vulnerability? Well, historically, nothing. Nothing is maybe a little bit blunt. Historically, very little, but there's two categories of vulnerability responses. The first category is the easier one, actually, is the FreeBSD only response. This happens when our software is broken, when we have done something catastrophically stupid in our kernel, or when we have broken something in a userland application, or just a subtle bug that affects only us. And maybe, so FreeBSD only response, we also include things like, it's not just FreeBSD, but it's OpenBSD and NetBSD. We just, they're friends and family, and they're very easy to deal with because we share mailing lists and we meet each other at conferences, and we just, hello friend from OpenBSD, we found a bug in FreeBSD and we think it affects you as well. That's very easy to coordinate. FreeBSD only responses also have no major risk of exposure, again, because the BSD communities are a fairly tight-knit family and we all know each other. Examples of these kinds of vulnerabilities, Gordon picked two, one from last year and one from 2 years ago. The first one was in April last year, affecting VT, which is our virtual terminal system. So what you use when you're logged in on a FreeBSD console and typing things at the keyboards. That's a very simple source of security vulnerability. I don't remember what the vulnerability was, but it affected only FreeBSD. And it was fixed. We fixed the patch, and then about 20 minutes later, we sent a security advisory saying, "Hi guys, everyone who is running FreeBSD versions between version X, where the bug was introduced, and version Y, where we fixed the bug, please update." And that goes quite well. KLD stats, I think, was one where we shared the bug with either NetBSD or OpenBSD. I can't remember. KLD stat lists kernel modules that are in your system, and under certain circumstances, something could go wrong, and you could gain elevated superpowers on your system without having been blessed with them. Not very smart. But again, this was really easy to deal with. We talked to our friends at the other BSD's security team, and we got the bug fixed, sent an advisory, everyone was happy. A much more complicated scenario is when multiple vendors are involved, and when there's, and even more complicated when there's non-disclosure agreements and explicit embargoes for really wide-ranging vulnerabilities that affect a huge number of vendors. Usually what happens here is that the response gets coordinated by either the private party that reports the vulnerability, usually a company, or a CertCC will coordinate the response. And this sort of coordinated response vulnerabilities generally requires very limited disclosure because we are trapped. We have a non-disclosure agreement. We can't just tell the entire FreeBSD community on our open mailing lists, which are archived publicly for everyone to see, that, hi, we have a security vulnerability in, to pick a hypothetical example, WPA supplicant, which affects every operating system known to man, including FreeBSD. By the way, the reporter has asked us very nicely to not make this vulnerability known to the whole world. Not a great idea. good examples of this category of bugs were the speculative execution bugs, Spectre and Meltdown last year, where a lot of operating systems and a lot of vendors are involved. To a lesser extent, the debug registers, where again, Intel CPUs were not as secure as we previously thought they were. And then we are usually informed, well, hopefully we're informed by whoever is doing the research. But unfortunately, we don't always get informed. So in the case of FreeBSD only responses, it's kind of easy because people know that FreeBSD is vulnerable because it's the only one that's vulnerable. In the case of more widespread vulnerabilities like the speculative execution, if you don't know that FreeBSD exists, if you do your research on Linux, Windows, or macOS, and you don't know that there's this other operating system that's driving quite a lot of people's stuff, then we just don't get informed. If we don't get informed, we can't fix it. And if we can't fix it, we can't tell anyone that we fixed it. So vulnerability response is actually kind of difficult. It depends on being informed in the first place. And then once we've done that, how do we tell everyone that we fixed it? So we have a security officer, this thankless job. And a security officer it's one person, but we have a team of people who work on the security officer team. And they do a bunch of things. So resolving disputes involving security, that's a fairly broad category of things they need to do. It's many developers of the operating system write software and just want the software to work. And it's very easy in a language like C, in which we develop our operating system, to make mistakes that lead to bugs. And sometimes this can lead to discussions and disputes about, is this the most secure way of doing it? Is this the most secure way of doing it? And the security officer needs to try to be active in the developer community to make sure that we write secure code. The security officer also has to fix the bugs that affects FreeBSD. If we are told about a bug by some external party, the security officer is responsible for ensuring that it gets fixed. The security officer writes the security advisories. This is actually the most boring part of the job. You need to actually sit down and write an essay about what went wrong, how we fixed it, and when we fixed it, and who is affected. That's a very important chapter. The security officer mailbox also gets a lot of email from vendors vendors and consumers asking, is FreeBSD vulnerable to this? Well, this is the first time we've heard about this issue. We don't know. And then, that response needs to go out rather quickly. If someone sends us an email on a Monday saying that, we think your network stack is broken in such and such a way, the best time to reply to that email is right after it was received, not 3 weeks later, which by then the vulnerability might have become public. The FreeBSD security officer should also try to audit as much code as possible and monitor bug reports on other operating systems. So we can't just sit around and expect people to tell us that we're broken. We need to be on VendorSec, we need to be on OSSSec and all those mailing lists to check, Linux sprung a leak here. Did we make the same mistake? Or Microsoft has sprung a leak here. Did we make that same mistake? So that sort of thing does happen. And the security officer also needs to be present in architectural discussions to make sure that large subsystem overhauls are actually done in a secure way. And finally, the security officer maintains the security officer PGP key. So we prefer that when vulnerabilities are disclosed to us that they are encrypted so that whoever's monitoring our email, hello NSA, are you listening? That they don't learn about our vulnerabilities before by just that's a great way to mine vulnerabilities, right? Just intercept email going to security officer teams, and you get a large and full feed of security vulnerabilities sent straight to your mailbox. So that needs to be encrypted, and that PGP key cannot just be left unwatched and unguarded. So there's some challenges with this. That's an extremely broad mandate. That's a lot of work. It's too much for one person, and it's actually too much for a volunteer. But on the other hand, it's also a lot of hurry up and wait. Right? So you just, suddenly everything is very busy. Meltdown Spectre, suddenly all hands on deck and just get to work. And then there's 6 months of silence until, I don't know, NTPD springs a small leak, and then there's a month of silence again, and then SendMail needs to be updated. So it's a lot of hurry up and wait, which is not exactly conducive to a friendly employment environment. So you go from periods of massive activity to periods of just doing nothing and waiting for vulnerabilities. You could spend this time auditing code, but then by the time you've finally got yourself stuck into a new piece of code, there's a vulnerability, drop everything, and get back to vulnerabilities. There's also a very high level of technical knowledge required to respond to the wide variety of issues. You might be very good at being a network stack developer, and then the next vulnerability is OpenSSL. I know nothing about OpenSSL, so it's very difficult finding volunteers for the security team. So the results of these challenges are invariably a burnout. So we went through quite a large number of security officers in a short period of time because you just get burnt out. It's demanding work, and then there's lots of sitting around and do nothing. And also, there's not many people who can think, who have a broad enough field of experience to do a security officer kind of job. So fixing it, yes, FreeBSD, we fix things. How are we fixing it? Well, we're fixing it with new blood. The security team mailing list up to about a year ago had, I think, 20 people on it. So it had all the previous security officers plus people who had volunteered to work on security. And we found that the mailing list was largely idle because everyone was expecting everyone else to respond to the vulnerability. Oh, this is a mailing list with 20 people. I don't really have time today. Hopefully someone else has time. If everyone thinks that way, nothing happens, right? Because everyone is standing around waiting for everyone else to do things. So we fixed that by appointing a security officer and actually paying for the time. I'll come to that in a slide. Of Summit volunteers. We've split the technical resource requirement from the vulnerability response requirement. So the person replying to the email is not necessarily the person who's going to fix the bug. The people on the security team, their primary job is ensuring that we respond to vulnerabilities, even if it's just sending an acknowledgement that, hi, we have seen your email, and we'll now we'll discuss this with the team and address the vulnerability if there is a vulnerability. So the security team now has a secretary, and he just email comes in and he replies to it. He's in a time zone in the Netherlands, but he's awake every day and replies to email every day, and that works quite well. And this allows us to use non-technical resources and gets our technical resources to focus on the bugs. So to people who are actually fixing the security bugs don't need to also monitor an email, a mailing list every day and respond to email and then, possibly coordinate with people they wouldn't ordinarily coordinate with. So the FreeBSD Foundation is now involved in the security process of FreeBSD. We have a couple of NDAs with larger vendors of stuff that uses FreeBSD and of vendors of things that FreeBSD runs on. And this is important for the survivability of changeover in the security officer. So our current security officer is Gordon. If one day he decides to stop being the security officer, then we don't want to have to go and renegotiate all the non-disclosure agreements he has in person by the next person. So the FreeBSD Foundation holds those non-disclosure agreements and vendor relationships as a legal person, as an entity. And the FreeBSD Foundation also manages vendor relations with larger companies who are traditionally reluctant to deal with individuals but are perfectly happy to deal with organizations. The FreeBSD Foundation also has money and can fund things. So we now pay for the time of our deputy security officer. So the deputy security officer is employed by the FreeBSD Foundation, and a certain number of hours every week are earmarked for security work. So if there is a security vulnerability, his time is paid for. If there is no security vulnerability, he works on other things, but a certain fraction of his time is earmarked for security work. We also pay for the security officer's travel. We would like to send Gordon to first TCs. He couldn't make this one, he couldn't make the one in Kuala Lumpur, but we have budgets to pay for his travel, and he should really be giving this presentation. But in his absence, the FreeBSD Foundation paid for my travel. Great. The FreeBSD Foundation also pays for development resources to enable these responses. So we pay for one guy's time. We pay for Kostik, who is a great generalist, and he works on every part of the FreeBSD kernel. So I don't think there's any file in the operating system he's not touched at some point in the last 20 years. But we now pay for his time, basically full time. And that helps a lot. So all of the Meltdown and Spectre vulnerabilities, we could not have fixed those vulnerabilities as quickly as we had without being able to pay someone full time to do this work. And that's in open source. That's kind of a novel idea. Paying someone to work on open source software is a fairly novel construction. So a case study with the new security team in place, this all went well. This was the debug registers in Intel that were not as secure as they were thought to be. It was a multi-vendor response, so every operating system that runs on any CPU was vulnerable to this class of vulnerabilities. Microsoft contacted the FreeBSD security team saying that, hi, we are aware of this vulnerability, and we think FreeBSD is vulnerable too. We have a patch against our system. Would you like the patch to compare it with you? In that discussion, we had representations from all the other BSD projects, from Microsoft, from Apple, Citrix, and VMware. So large Citrix and VMware have hypervisors that were also vulnerable to these problems, and a lot of Linux distributions. So it was a small group of people responding to the same vulnerability, and lots of collaboration went on with proofs of concepts, especially with the other BSD variants, because our kernels are very similar. We had one CertCC who were in charge of coordinating the response, and with their blessing, we were allowed to inform one of our downstream users. So pfSense is a distribution of FreeBSD that's particularly used by firewalls, but because they're not FreeBSD, we can't, they're not covered by our non-disclosure agreement, they're not covered by our permission of the embargo. So, we had to ask the CertCC, hey, so we fixed this in FreeBSD, but these guys, they're downstream consumers of FreeBSD, can we tell them? And CertCC gave their blessing and said, okay, fine, do it. So pfSense was fixed at the same time. 1 hour after the embargo was dropped, we patched FreeBSD. We committed it, exactly an hour later, and we beat Red Hat with our patches. So that was always nice to see. We beat Red Hat on other fronts as well, right? We're just a better operating system. But it's nice to be able to beat a large, well-funded commercial operating system, by a smallish group of volunteers. So I think that gets me out of this presentation. I was a bit fast. I hope to get a bit of a discussion going. You're all certs and CCs, or most of the people in the room are from the coordination side of the fence, whereas I do operating systems and I write bugs. So what can we do better? Did you know about FreeBSD in the first place? Are you going to tell us when you discover a vulnerability? Would you please test your vulnerabilities on FreeBSD and let us know if you find any? So that concludes my presentation. I'm happy to take any questions. Are you all asleep? Yes. You can borrow the microphone. You can also just shout it.
I'll get the ball rolling. So thank you for your presentation. I have maybe one or two questions. So the first one is, do you think with the current model of FreeBSD Foundation funding a security officer or two, was it 2 officers? So what would be the challenges of sustaining that in the long term? Um, The other question that I have is, this morning there was a presentation about I think, supply chain attacks, where attacker can creep into software or infrastructure and things like that. So how worried are the FreeBSD folks or foundation in this form of attack where you have a lot of ports and packages and you have your mirrors everywhere? And yes, go ahead.
Hi, I'm not really understanding about this like technology things because I'm far away from like a free BSD, something like that. And so I just found some interesting website. It's compared to the free BSD and Red Hat. What country is really like to use this like database for operating system? It comes out like Red Hat is like leading in the most country like United States and Japan and Canada and the United Kingdom. And but other hand, but FreeBSD is like for Switzerland, Germany, and Russia. It's something like Europe for Europe. Do you know why it's happening to so different countries really tend to use this different operating system for their business?
Maybe if I turn it on, yes. It's an engineering problem. So as I said at the beginning of our presentation, the FreeBSD project really doesn't know where our software ends up because the vast majority of people who are running FreeBSD are not actually running FreeBSD as we distribute it. The FreeBSD is the sum of its parts. And companies like, do you count every Juniper router as a FreeBSD device? Do you count every iPhone as a FreeBSD device? I wouldn't. So that website with your statistics, it might be counting web servers, and if you're counting web servers, what you're doing is you're counting web servers which choose to disclose their operating system, which is not all of them. So I think it is really difficult to count the number of FreeBSD installations, and it is even more difficult to try to pinpoint their locations. So I've seen many statistics of, FreeBSD is dying, nobody uses FreeBSD, but then, okay, that's a fair point. Nobody who is using FreeBSD is disclosing it in their web server headers, or no one who is, and FreeBSD clearly is not a very popular desktop operating system. But FreeBSD is not just the operating system which you install from the ISO. FreeBSD is also all the bits and pieces of our kernel which other people pull in. And sometimes that goes very far, right? So Apple picks up our network stack and other bits and pieces, most of our user land, and Juniper picks up our kernel. So those are large bits of FreeBSD. There's more obscure users of important bits of FreeBSD, like the Artems real-time operating system also uses FreeBSD's kernel, and Artems is a very different operating system. Do you count every Artems installation, of which there are possibly hundreds of millions, as a FreeBSD installation? I wouldn't. But if the parts of FreeBSD they pull in are the parts of FreeBSD with bugs in them, then I won't say I feel responsible. I'm irresponsible, but I still feel slightly culpable.
Okay, but one thing that I think it's gonna be a good news for you, but for website for the science, they love to using FreeBSD.
Oh, yes.
BSD and this
Yes.
so.
FreeBSD is historically very popular at universities and research institutions because researchers like good things, I think. Yes.
That's
and free things, yes. Yeah.
Is there any other questions for Philip? Excellent. Well, if everyone could join me in thanking Philip for his presentation.
Thank you for having me. I hope I'm allowed back.
And it's going to be a afternoon coffee break time now, so we'll be starting back again at 4:30 on the dot. So please join us then. Thank you.
I like this graphic. Well, you're not alone. You are not alone. You are not alone. I ran FreeBSD on my desktop until 2008, and then Apple released a laptop which is the right shape. Let's try one of these. Managed to leave people on time.